sinusoidal graphs. Sinusoidal graphs we saw were sine and cosine because their period was 2 pi. So every 2 pi, the pattern repeated itself. In today's lesson, we need to talk about other trig functions that have different periods. So we're gonna start with tangent here. I've got a picture of tangent, so we should identify its parent function provided. The domain, we can see that there are some vertical asymptotes that are going to continually repeat. And when I look at my graph here, I see that these are repeating every pi over 2. And every pi over 2 happens every pi itself. So our domain of theta cannot be pi over 2, which is repeated every pi. So it's a multiple of pi. At the same time, though, our range is all real numbers from negative infinity to positive infinity, since we start way down below and we continue forever and ever. The distance between when we have a start and stop of a repeat of our pattern is every pi. And tangent here is an odd function. It's an odd function because if I have a tangent of negative theta, we know tangent is the same as sine over cosine, so sine of negative theta over cosine of negative theta. Based on our even odd functions from our last lesson, I know that when I have sine of negative theta, I can bring that negative to the outside. And cosine, there was no change, it's just the same. So sine we know is odd. So if our numerator is odd, we know cosine is even, therefore tangent must be odd itself. And then this gives us negative tangent of theta when we simplify. So therefore it is odd, similar to sine. Now our bottom function graphed here, what looks like it's flipped over, this is cotangent. So our graph here is cotangent of theta. Not only is it kind of reversed and flipped, but theta, in this instance, every pi is when that we are starting to, we have a vertical asymptote. So 3.14159, 6.28, etc. Every pi, it repeats itself. So therefore that leads us to the period is pi as well. So every pi is where the domain has a vertical asymptote, and its period is also pi. Its range is exactly the same as tangent, negative infinity to positive infinity. And it is also odd because ultimately we know that cotangent is the opposite or reciprocal of tangent. So this would also provide us with a negative cotangent of theta as well. Moving on to our first example, let's find the equation or the formula for the function that is graphed here. When I'm looking at this, I see that we are in the shape of tangent. Repeats itself. It looks like from -4 to +4. So the period is 8. When I look at specifically this particular point, 2, 2, it appears that all input values and remember our input values, our theta, are stretched. So it looks like we're being stretched left and right compared to where our original tangent's a little skinnier and taller. This seems to be stretched out a little bit more. Because we know we can state that our b value is equal to, since we repeat every pi instead of every 2 pi over our period. So this is going to be pi over 8, since our period is 8. We can state that our general formula is the amplitude of tangent of k theta. So now that we have a general value, we need to talk about how we obtain A in a second, because A is associated with the vertical stretch. But we do know right now that pi over 8 will be replaced with K, since K is our stretch that's happening here. But we need to know what A is, and that's associated with our vertical stretch. And we're going to use a point that we have, 2, 2, to solve for A. I know that this value here, 2 is our theta, and the other 2 is f of theta. So therefore I have 2 is equal to A times tangent of pi over 8 times theta, which is 2. 2 is equal to A times tangent of pi over 4. Using my unit circle or using our exact trig values, I know that pi over 4 is equal to, so tangent of pi over 4 is equal to 1. Therefore, A has to equal 2. So our final function for this tangent, f of theta, is equal to 2 times tangent of pi over 8 theta. Notice I've got our example already graphed. It's asking us to sketch the graph, which we know that My Open Math likes us to graph. So we're just going to verify some items based on what we know about the different components. So when I look at f of theta is equal to 3 times tangent of pi over 6 theta, what I know is this. I know that this 3 is our A, and that tells me I'm vertically stretching. By a factor of 3. I also know that pi over 6 is my horizontal stretch. I know then that my period is 6, since we have pi over the period, since tangent repeats itself every pi. And then utilizing Desmos to help us, which is a neat feature. All right, let's head over and talk about secant and cosecant. So we know that secant is the same as 1 over cosine. So secant is going to be undefined because we can't divide by anything by 0. So it'll be undefined. Where cosine is 0. So anytime cosine is 0, we're going to have some vertical asymptotes. Looking at our unit circle, we will have vertical asymptotes at pi over 2 is where cosine is 0, and 3 pi over 2. Ultimately, to get from pi over 2 to 3 pi over 2, we're just adding pi. So our domain will be everything except pi over 2 plus multiples of pi. Because if I add pi, I'll get 3 pi over 2. If I add pi, I'll get 5 pi over 2, etc., etc. When I'm looking at my picture on the left, the red line here is cosine, so we can kind of see how they're related together. The red line is cosine. Notice then that wherever cosine is 0, wherever it's crossing this axis here, we're ending up with that vertical asymptote every single time. Every single time that happens. Also note that we have some horizontal asymptotes, right? Because we never are in between -1 and +1. So our period is every 2 pi, we repeat. So every 2 pi, so from, if I started, one rotation would be this entire piece, both a downward and an upward item. So every 2 pi we have a period here. Our range, we're starting from -infinity. We go all the way up to -1, where we stop. We hop over the graph of cosine itself, and then we continue back up at +1 to +infinity. Well, let's think about whether or not secant is even or odd. So if I put the negative inside my function and evaluate it, I'll have 1 over cosine of negative theta. And I know that cosine of negative theta is just cosine of theta itself. So therefore this would just be secant. And since it doesn't change anything whether or not I have the negative on the inside or not, just like cosine, it's even. Which leads us to a very similar graph with respect to cosecant. Similarly, with cosecant, I know cosecant is the same as 1 over sine. So our graph is going to be undefined. Where sine is equal to 0. Looking at our unit circle, we're going to have vertical asymptotes. It'll be undefined. At 0 and at pi. So again, I'm still adding multiples of pi to get where I start. Our domain then, theta cannot be pi, which are multiples of pi. Because I would have the next one, if I add pi, I'll have 2 pi, 3 pi, 4 pi, 5 pi, etc., etc., etc. So our period is 2 pi, very similar. It contains both the up value and a down value. Notice my red line here is sine. So I've got those vertical asymptotes at every pi. Our range, very similar. We've got those horizontal asymptotes happening. So our range is -infinity to -1, and then 1 to positive infinity, since we're skipping the graph of sine in between. Now, if we want to determine if this is even or odd, again, if I'd have cosecant of negative theta would be equal to 1 over sine of negative theta, and 1 over sine of negative theta, we know that the negative comes out front, so I have negative sine of theta, which would then give us negative cosecant of theta. It's not the same, so just like sine, cosecant is also odd itself. Sketch the graph of 2 times cosecant of pi over 2 theta plus 1. So of course, definitely utilizing Desmos to help us. We will look at some items and how they're related to one another here itself. So if I look at some items that are located here, we've got ourselves this 2 here out front. This is our vertical stretch of 2. So we're getting skinny. If we look at the inverse of pi over 2, we can see where we're going to end up with multiples. Since this is cosecant, which is related to sine, theta is going to be equal to 2 over pi times multiples of pi. So when I simplify, we will have vertical asymptotes every two times our value itself, whatever we're inputting. We have this plus 1 on the outside, and we know that this plus 1 tells me that we're going to shift up 1 unit. We notice that our range is a little different. Right, our range, since it shifted up 1 unit from 0, everything is shifted up 1 unit. I see in my graph, that my range goes from -1 to +3. With respect to its graph of sine. However, with our cosecant graph, we know then that our range is going to start its opposite, so from -infinity to -1, and then again from +3 to +infinity. We also know that our vertical asymptotes will help us find our domain. So maybe I'll highlight this and then we'll look at our domain. Based on what we've discovered with theta, domain everything except multiples of 2k, and we can see that also within our graph here where we have -4, -2, 0, +2, +4. So notice they're multiples of 2. That is where our vertical asymptotes are located. And just as a reference, this graph is related to the function 2 times sine of pi over 2 theta plus 1, which is kind of interesting since that would give us the graph in between. Ready to touch down, come back up. It'd be related to that graph. Oops. It'd be related to this graph of sine. It's pretty interesting. All right. Given the graph of 2 cosine of pi over 2 theta plus 1, show and sketch the graph of 2 secant pi over 2 theta plus 1. This is pretty interesting because they want us to graph it on the same axes, which is very interesting. So we know that these obviously are related to one another based on our last example, where if all I'm doing is replacing secant and cosine, the same is going to happen if I do sine and cosecant. I do know that there's going to be, wherever we cross here within cosine, that is where we're going to have a vertical asymptote, because it's undefined at those locations. And I do know then that the graph of secant is just going the opposite every time we have a valley here. Will be going up or down in its respective location. And you could also graph on Desmos too, typing it exactly as we see it, which is very interesting. Now we've got our negative angle identities that we've really focused and honed in on a lot. And so we haven't done a example of proving a equivalent identity. So that's what we're going to do right now. We have tangent equal to negative cotangent of theta minus pi over 2. This to me looks like a cofunction on our identity sheet. I wonder if we shouldn't start on the left-hand side and see if we can't be creative with how we manipulate our items. So I'm going to start with tangent and turn it into sine and cosine. Then I'm going to use my cofunction identity. When I use my cofunction identity, notice that by using the cofunction identity, it turns the sine into cosine and the cosine into sine, which is pretty interesting. Well, now that I have cosine over sine, I know that when I have cosine over sine, doesn't matter what's on the inside as long as they're the same. That's using the cotangent identity. So cotangent of pi over 2 minus theta. We're getting closer, except these are not the same yet. They're not the same yet. I can rewrite this as cotangent of negative theta plus pi over 2. So at least it's in the same location. It's just that our negatives are different. But what if I took cotangent, and I factored out a negative from this group, so I now have a positive theta with a negative pi over 2. So now we match underneath here and here, except I have this weird and wonky negative, but I know that with cotangent, this negative, because cotangent is an odd function, I can bring this negative to the outside, giving me a negative cotangent of theta minus pi over 2. And now our negative is out front because it's an odd function. And that takes care of looking at other trig functions, definitely utilizing Desmos to help us graph and see the comparisons between the original parent function with its transformations among them is really what this section is going to boil down to within your homework. So reach out if you have any questions.